Hello, we are Team Traffic Control. I'm Brianna Williams, a second-year biomedical engineering student at UMass Lowell, and my partner who is unable to be here today is Jacob Marinelli. He's a third-year mechanical engineering technology student at Rochester Institute of Technology. When looking, we determined one of the biggest issues involved for construction. When you come up to a road where there's one lane of traffic, we noticed somebody was there directing traffic or some sort of timed interval that we would want to make this more efficient for the driver as well as create a safer environment for flaggers and police officers, which are both very dangerous jobs. And most people in our society are on our roads every day and they need to keep up with the construction that is constantly around us. When looking into the opportunity that we had, there was no motion sensor option out on the market, and even though the job of flagger is one of the most dangerous, with 41 out of 100,000 people killed each year, with that being said, roadways are also a $92.5 billion U.S. industry expected to grow another $103 billion by 2022. Unfortunately, due to the concerns of COVID right now, we did not be able to get in contact and reach out and physically talk to someone out in the industry who is directly involved with the hazards during construction, but we do have the future plan to talk to a representative from the U.S. Department of Transportation and Federal Highway Administration. As we were looking into more research, we noticed there was no other options out on the market that help reduce the time one spends near a construction site, as well as create a safer environment for those workers who working so closely with our roadway construction. To solve these problems, we devised a new control system that deals with both actively managed or a flagged scenario and an anonymous scenario. In a flagged operation mode, there would be a user who would control a remote controlled signal through an operator interface off the side of the road or in a protected area. This would make a safer environment for flaggers or police officers. Our system would also be able to provide insights into help the flagger make decisions in an automatic mode instead of a typical detection system that only detects the presence of a vehicle at a traffic light. Our detection system will identify not only the presence of a vehicle, but also the direction of travel and speed of the vehicle. These sensors will be placed at a distance determining the expected rate of travel and will communicate with the master module to determine which traffic paths should be prioritized. This system will also be capable of determining the number of vehicles approaching, something uncommon in traditional traffic lights as we see in today's society. As you can see here, there's 6 photos of our prototype that we use creating a 3D printer and a few small market hobbyist sensors that are relatively easy to obtain. As you can see in the top right-hand corner, it shows when a car drives up the motion sensor spot on the road, where the one lane of traffic and the light will turn green, and vice versa if to the right where there's no car on the sensor and the sensor is red at the time. As we go on, the bus would drive forward in the case scenario or a car, and then it would give them a timed interval of how long it would roughly take for this car to pass the series of one lane road, as well as another sensor at the end of the road to signify that the car has gone through the area and can let the other side car down the road. Right now, our resources are very minimum because of lack of funding, but currently we are working on improving code and hardware upon our existing prototype, continue researching commercial grade sensors that will hold up in an outdoor environment such as really cold, really hot, rain, snow, ice, etc. We also am planning to create a full-scale CAD model of what this whole system would act like. And then we want to also continue investigating new technologies that we would like to integrate in the future. In the future, We will obtain full-size hardware and appropriate sensing equipment in order to be able to complete a full-scale model, construct and evaluate the full-size solution, transition electronics from an industrial-grade PLC to improve detection algorithms, as well as create a mobile app for manual control that could be done from off the side of the road or in a protected area as a flagger would be, and integrate other needs and features that might become apparent in the future, such as a solar panel system to be able to have the unit be more portable than just a permanent fixture that might be obtained during construction. Thank you. If you have any questions, comments, or concerns, you can email us at my email and then Jacob's email.